Think of a pump station as the heart of a water transmission system, boosting pressure to send the vital life resource, in this case drinking water, out through a system of arteries or water lines to reach customers throughout the body, just like our cardiovascular system. We tend to take this amazing machinery for granted. The State Water Supply Department, in Malaysia, Regional Water Authority's Pump Station No. 1 plays a number of key roles. The complex includes millions-gallon storage tanks, a disinfection facility where water is monitored, sampled and managed in electrical controls building, standby power generators with capacity to operate the entire facility. In an emergency, and there's a storage facility for parts and equipment that also houses the operator's office, and computerized controls, as well as a SCADA system to monitor the entire operation 24/7. The water we conserve today can serve us tomorrow, with K-Design's PELGO Turbine. We've all seen the massive dams and aqueducts that provide power to cities around the world. But there's an untapped potential beneath our cities. Gallons of high-pressure water flowing through our water pipe infrastructure every day, wasted energy dissipating through pressure-reducing valves and canal drops. It's possible to recover some of that energy and put it to use. Let's explore energy recovery hydropower and how it could be a game-changer in micro-hydropower. Welcome to K-Design Creative Solutions, PELGO Turbine. Harnessing the power of water isn't a new concept. Between 202 BC and 8 AD, during the Han Dynasty in China, trip hammers powered by water wheels were used to pound and haul grain and break ore. The Greeks also captured the power of water for milling thousands of years ago. However, it was only in the 19th century that hydraulic turbines started to be developed. Since then, we've been producing clean energy from the force of water, and this power source accounts for 60% of all renewable electricity we consumed in 2020. The usual solution is to install pressure reduction valves, PRV. These devices release the pressure from the water, but they also lose all that usable energy. However, there is a small but growing move towards converting that wasted pressure into electricity and feeding it back into the grid, creating clean, usable, renewable energy that would otherwise be lost. This approach is called energy recovery hydropower. PELGO Turbine, from K-Design. Inline model is designed specifically for each site in order to achieve maximum efficiency, but shares a number of common parts for competitive pricing and quick lead times. These turbines are designed to recover power at flow rates between 500 to 30,000 gallons per minute, GPM. Their higher operational flow rates give them a lot of flexibility for what they can support, like public water supplies, agriculture, tunnels, canals, or aqueducts. This is a subset of conduit hydropower that harnesses the energy released by PRVs in current, pressurized, man-made water systems already diverting water from a natural waterway for consumption. These systems generally include a microturbine, generator, sensors, processors, electronic controls, and communications equipment that operate continuously and autonomously within the water utility infrastructure. PELGO water turbines can be installed in any water delivery network with excess pressure and are well suited for sites that have a relatively constant flow rate. PELGO offers pump turbine packages for both on and off-grid applications with outputs ranging from 5 kilowatts to 350 kilowatts and supports 500 to 9,000 GPM flow rates. Usually, the control systems of water treatment facilities get data about pressure and speed from sensors that constantly monitor the water flow in the pipeline and send that information to the operators to control the PRVs. Energy recovery systems are usually connected parallel to those systems. The diverted and parallel water flow drives a micro-hydro turbine that's combined with pressure control to produce and feed renewable energy into the grid. Control valves ensure that the diverted water flows back into the main pipeline at the correct pressure. Unlike intermittent renewables like solar power, one of the benefits here is 24/7 operation all year long. And from a system-level point of view, these turbines could replace PRVs, using the turbine itself as a flow control device. The primary market driver for energy recovery hydropower is the opportunity for water system operators to lower operational costs by offsetting energy use costs. In the U.S., energy consumption by water utilities represents 30% to 40% of a city's energy costs, mainly from water pumping. So why not install energy recovery turbines and tap into that wasted potential? And in some cases, produce a surplus that can be sold back to the grid. Energy conservation and renewable energy doesn't have to be a one-size-fits-all approach. It's not just wind turbines and solar panels that can solve our energy needs. PELGO Water Turbine. It's our main product, powered by K-Design, is a Malaysian-based specialist engineering company with unrivaled expertise in the field service of water turbine technology. Established in 2010. This Malaysian company has expanded substantially to become a well-recognized and sought-after player in the specialist field. This company refocused its activities in the market with a strong hydro turbine component, ranging from local manufacturing to installation of turbines. Recovery energy from water system operations. Malaysian technology, for Malaysian people with international standard. Our specialty is recovering energy at water system pressure drops by implementing our PELGO hydro turbines. Applications are found in nearly all drinking, irrigation, GDC system, centralized chilled water supply system. With these systems can be used on-site or sold to local utilities for profits or electricity cost saving. PELGO Turbine, designed by K-Design. Malaysia technology for Malaysian people. Thank you.